Hello, my name is Bittu and I am a student at NIT Kurukshetra and I belong to the branch of Microelectronics and VLSI Design. Today I am going to present you the project that is breast cancer classification using machine learning in Python. So first of all, let's get some brief understanding of the whole project. Primarily, breast cancer using machine learning is aimed to develop models that can classify whether a tumor is benign, that is non-cancerous, or malignant, that is cancerous, based on the input features or the attributes such as the texture, shape, tumor size, and the duration. This project is and ultimately going to be a binary classification task, that is to classify the tumor dataset into the two major classifications. They are the benign and malignant, which is the cancerous and non-cancerous tumors. It can also be a multi-class classification project if we consider various stages, types, and other kinds in the tumors. So let's get started with the code. Primarily, we know that we use many libraries, many Python libraries in machine learning, and few of them are the NumPy, Pandas, sklearns, and etc. Here in this project, majorly we use the NumPy, Pandas, and sklearn libraries. So we have to input them first, and you can see we have inputted them as shown here. Then we need to collect the data from data from the we can collect the data from the various platforms such as the Kaggle, mm, where the breast cancer data sets are directly available. So the data used in this project is derived from a fine needle aspiration FNA test, which is a type of bio biospy procedure where a thin needle collects tissues or fluids for pre-diagnosis. Pathologists use this method to determine if a tumor is being benign or malignant. That is, the tumor is cancerous or non-cancerous tumor. Let's get into the dataset details. The dataset here you can see is breast cancer dataset. This contains details about the benign and malignant tumors with measurements such as the radius of the tumor, texture, perimeter, area, and its smoothness, which are the properties of cells actually. In the sklearn dataset used here, 0 represents the malignant tumor and 1 represents the benign tumor. Uh, it can be B for the benign and M for the malignant in some other datasets. Here we use the notations as 0 and 1. Starting with the workflow for machine learning. First, as we all know, we need to import the dataset as a CSV file. This is known as the data collection. As you can see here, I have imported the breast cancer as the CSV file. Then next comes the data pre-processing. In this, we need to prepare the raw data for the model. This involves the loading of the data into a pandas data frame. For structured analysis, adding the target, that is label, which is simply a column to our data set, and then checking the shape, that is number of rows and columns similar to the size of a array, getting the information about the data types and non-known values, checking for missing values, and obtaining the statistical measures such as the mean, deviation, using the describe function. Next, you can see here, these are the first five columns of our dataset, that is from the index 0 to index 4. You can see all the columns Next here we added the another column named as label into our data set, and you can see that here at the last in the ending. Previously there is no label column. Here we added by targeting it as the label, and you can see it is here over there at the last. Next comes the number of rows and columns in the data set. We can find out this using the data frame dot shape. Here you can see it's 569, 31. That indicates there are total 569 columns, that is starting from the index 0 to index 568, and 31 columns together in all, including the label. This is the last 31st column. Now, getting some information from the data, we can see we have loaded the data into a pandas data frame set, and you can see various attributes such as the mean, radius, texture here, and all are of the float data type. Next, now statistical measures about the imported data sets. We can find out this using a describe function. Here we can majorly see the parameters such as the mean, maximum and minimum of some selected columns. Here it calculates the error, the best and worst values, and the precise label values as shown here. Here we indicate the benign type of tumor with 1 and malignant type of tumor with 0. It is mentioned over here. You can see that. Next, now here as you can see, we have splitted the data into the training and testing data. From the data set that we have imported, majority portion of the data will be used for the training purpose, and some part of it will be used for the testing purpose. Uh, Here as you can see, model training. We have trained the model here using the logistic regression model for the binary classification, that is classifying the data into benign or malignant type of tumors. The model is trained using the training data as shown here. Then comes the model evaluation, which means the accuracy of the data that we have trained. Data evaluation involves in assessing the model's performance using the accuracy score. The accuracy is calculated for both the training data and the test data, checking that both are crucial to detect overfitting, whether a model performs well on training data but poorly on new data. Accuracy is a factor that how clear is our data. It shows the exact accuracy that the cancer is tumorous or not, the tumor is cancerous or non-cancerous. More the accuracy, more the chances of cancerous tumor. Next, building a predictive system. Building a system where futures can be new data, that is the futures. They can be fed to the trained model to predict whether the tumor is benign or malignant, that is cancerous or non-cancerous. This involves converting input data to a NumPy array and reshaping it for a single data point prediction, as you can data point prediction as shown here. If the prediction is equals to 0, then the breast cancer is of the malignant type, that is the cancerous one. Else it will be the benign, that is the non-cancerous one. Here you can see it is 1, so the breast cancer is benign.